Okay, so as I promised that I will continue with the separated video, the last part of, I believe, chapter 12. So we start last class talking about selection structures, and we learned about the if and if-else statement. We talked about the nested if statements, and we saw some applications for those using selection structures. We started by checking if a path does exist, and we checked also if a user does exist. And then after that, we moved about how do we compare numbers, and we talked about how do we compare integers and how do we compare numbers with decimal point. And then we ended up comparing strings. And the difficult part, I will say that each one of those data types has a different way to perform some comparisons. It's just a matter of getting used to, keep practicing till you actually get familiar with the whole concept. One of the things that you should know about these selection structures in bash scripting is that the final decision, it's simply going to be made based on the exit status of the execution of the command that comes with the if statement. So every single if statement will be followed by a command, and based on the exit status of that command, simply a branch of the script will be executed and some other branches will be simply ignored. And we simply said if the exit status of the command was 0, that simply means it's going to be evaluated. If I want to put it in a very similar way to how programming languages works, the exit status 0 is equivalent to true. Exit status of 1 is equivalent to false. And if you have a background in C++, you will notice that it's kind of the opposite of how C++ works. Again, evaluating of expressions in C++, if it's 1, it's treated as true. If it's false, it's treated as 0. But again, that's again a little bit different. But this is the part that, again, as I'm a programmer in the first place, I found that this is a little bit confusing for me to know that exist 0 is the true and exist 1 is the false situation. So let me just go back here. We learned about how do we compare numbers, integers, compare numbers with a decimal point, and we learned about how to compare strings, and we learned how do we check if a user exists, and we also learned how do we check if a path exists. Now we're going to move on and talk about dealing with files and directories. We also can perform checking for directories and files, and to do so, I'm just going to go ahead and, like every class, I will create a new file. I will just say my bash.sh, and let's change the permission, user plus x, my bash. And then after that, we will vim my bash. And remember, we always start with, wait a minute, insert mode. Bin, and then bash. Let me just echo to make sure that it's going to work. I think it will. Test. And let's exit WQ. And let me just start again. Home, faculty, home, faculty, Eljanab, and my bash. Okay, just remember that I had to go all the way no, I'm still in my folder, so now, and you can see it works. Okay, that is good. Let's go ahead and go back to the Vim so we can actually start updating this code. So now what I said, simply, I said we're going to go and test files and directories. Now, before I just jump into how do we perform that, we just need to know that we have some comparison operations, or let me just go and open the PowerPoint. Nope. Where's the PowerPoint file? Okay, I have to drag it from here. And here we go. So this is, again, how do we test files. So you can see here, we have the comparison operations, okay? And each one of those letters simply means something. This file, again, you have to put the path, the absolute path. And again, the path that we're talking about here could end with a directory or could end with a file. Now we know that with Windows, we know a file from a directory. When you look at the path, it's simply by looking at the extension. If the path ends with an extension, you know that this is the end of a file. If the path doesn't end with an extension, that's simply a directory. But again, no extensions are available in Linux. So when you look at a path, you're not sure if the end of that path is a file or a directory. And here what we can do, we can check. So if you put the path and you put -d, simply you're checking if it's a directory. And if you put -f, you're checking if it's a file. And if you just put E, you don't care. You just want to check if it does exist or not. Of course, it has to exist, and it has to be a directory. It has to exist, and it has to be a file. But if you don't care if it's a file or directory, you just want to know if it does exist, you put in E. If you want to check if the file is readable, simply means you don't have problems, permission problems with reading the file. So that's an -R. If you want to know if the file does exist and it's not an empty file, you put in -S. If you want to check if it's a writable, that you can actually write it, and you want to check if it does exist. So both of these two conditions has to be true. You put a -W, and then after that, we have the uppercase X and uppercase O and uppercase G. Uppercase X, again, it's if it's executable. And O, it's simply if the user owned the file, the current user owned that file. So simply, if I check for a file that does exist and I'm the owner of that file, then yes, it's going to give me true, or exists, so 0. But if you're trying to have access to a file and you're not the owner of that file, you're going to get the exist states of 1. G, of course, is for the default, for the groups, to see if that file does exist, and it's a default for a group that has the same as the current user. Now also we can check if a file is newer than another file. Simply by newer, and simply means you're checking about when were those files created. So you check that part, you can tell which file is newer than. You can check also if a file was older than another file. And of course, do not forget the square brackets. Now we know those. We can go and give this a try. So for example, if I say path, or let's call it my path, equal, and I'm going to put home faculty Al-Janab. And actually I need to go and check for a file and see if that file does exist. I'll just keep it like this. Okay, and then I'll update it later. I'm just showing you the context here. And always remember there are spaces. And I'll say -D and then $my path. So again, I'm checking if this file does exist and it's actually a directory. Then let's echo. And we'll put directory. Let's see here. Directory. Okay. And then we'll put else. Echo. Let's say not a directory. And then of course FI, we don't forget about that. So let's go and exit and WQ, and let's give this a try and see. Well, it says it's not a directory, and it says I'm missing something. Okay, so let's go back and see what have I missed. Oh yes, I know what I missed. I made a mistake. Let's put an I. There's this space here. Let's hope that will fix the problem. And you can see here now it's telling me it's a directory. Let me ls my home directory. Let's see, if I type pwd, this is my current, sorry, pwd. Okay, if I type, let's say, not change directory, I want to ls. Okay, so here we go. Those are my files. I want to just check my data. I'll go and check for that, my data, the text file. Let's go back to my Vim. And let me just show you that I can come here and put my data.text. And now, since I'm checking, I'm having a file, I will change that to be an F to check if it's a file. Of course, if I keep it as a D, it's supposed to tell me that this is not a directory. But again, let me just change this based on that. I'll just put it's a file. And here I'll say it's not a file. And now if I run it again, and you can see it's a file. So I don't need to really go through them all. You can give them a try, but what you should know, again, in the future, when we're going to write scripts, you can check if a file is readable, is executable, it's owned by a user, if the file does exist, and if you can check if it's a file as a directory. So you do have that list of options that you can try when it comes to testing files. So that was the first part that I wanted to cover in this video. Let's see what else we can check. I'm going through the PowerPoint, so I don't want to skip any points. Oh, yes. Let me clear. And let's go back to Vim. Now, what we can do also, sometimes you want to check for multiple entities, like you have multiple things to check. And we want to have some sort of tools that we can combine those checks together. Now, we simply have two ways to combine those test commands. We have the AND and we have the OR. And this is, again, something related to logical operations. And again, I'm pretty sure somehow, somewhere, you learned about them. But whenever you have two expressions, and those two expressions, again, we can consider them Boolean because you got two different values that could be the outcomes of it, 1 and 0. Remember here, 0 stands for true in this case, if you want to put a similarity with the programming languages, and 1 is for false. The idea here is that with the AND operator, both ANDs has to be equivalent or evaluated, or the exit status to be 0, 0 for the final outcome of both expressions to be 0. Otherwise, it will be false. It will be 1. So what I'm going to go here, just to give you an idea, if we have a variable 1, and we'll set variable 1 to 10. If I have variable 2, and we'll set variable 2 to 20, I can do the following. I can say if, and I'll put $var1, let's just put greater than 5, and I'll come here and put and I'll put here $var2 is less than 30. If that's the case, then just echo true, else echo false. If I. So here we go. We have two variables, 10 and 10, and I'm asking here, if the variable 1 was greater than 5, at the same time, variable 2 is less than 30. If that's the case, echo the value true, otherwise echo the value false. We can check again for ranges sometimes. Like, for example, I want my value that I'm holding to be in a specific range, so it's supposed to be greater than one specific value and it's supposed to be less than one specific value. Well, you know what, here, let me just do that here. That'll make more sense. If I take this one away, and I'll say if the value 1 is greater than 5 and value 1 at the same time is less, wait a minute, value 1, just put it here, was less than 20. Okay, so what I'm checking here, I'm checking if the value 1 is in the range 5 to 20 without including 5 and without including 20. Of course, greater than or equal, or less than or equal, and I can change this one to be, for example, 10 and this to be 5. And simply I'm asking if the variable 1 is within the range of 5 and 10. So simply if variable 1 will hold the value of 5, 6, 7, 8, 9, and 10, any of those values, then it's simply going to be acceptable. So let's exit and save the work. And now if we go back and run it, oops. Oh, my bad. I'm in the right place. How come he didn't know it? Huh. Did I make a mistake here or something? Bad interpreter, no such a directory. Huh. What just happened here? I didn't change anything. WQ. Clear. Where am I? I'm in the root directory, I believe so, because if you look, here's home. Oh, my bad. I was trying to run it. Oh, come on. Oh, bash 1, bash 1. I think I know what I did. I made a mistake, probably, in the Vim. Oh, here it is. Where's this one came from? Take that out. Okay, that's a good thing that I was able to tell. And here we go. You can see it's true because, again, that value is within that range. What we can do too, we can use the OR operator. Now for the OR operator, simply we change the value here. Change the operation to be OR. And here's the OR operator. Now the OR operator simply means one of them has to be true. Okay, one of them has to be true or exit. In the previous one, when we're talking about AND, for this true to be printed, the exit status of the first expression vr1 greater than or equal 5 has to has exit status of 0, and variable 1 less or equal 10 has to has exit status 0 as well. But when we use the OR operators, logical operator, simply means one of them has to be true for the whole thing to be evaluated as true. And in a case like this, we see that the G10 VR here, if I come here and put a value, let me go back. Let's see here. If I put any value that's greater than 5, it's going to be acceptable, and any value that's less or equal 10 is going to be acceptable. So this simply will include everything. I believe so, because if I put a value that's greater than 5, so that simply means anything greater than 5 is going to be acceptable, and if I put anything less than 5 is going to be acceptable. So it doesn't make that much of sense here. But let me see if I can think about an example. I'll just take this out. I'll just put variable 1 equal 5. Or let's put it 15. Variable 2 equal 20. And I'm going to come here and say if variable 1 is greater than 5 and variable 2 is less than 20, and here I'm going to put 25. Okay, so let's look at the evaluation here. Variable 1 is equal 15, and since 15, if you compare 15 to 25, and I'm saying 15 is greater than 25, that simply means this is false. So the exit status here is going to be 1. But the other side, we have variable 2, which I'm asking if it's less than 10, and it is less than 10. So the final evaluation for both of them is simply going to be exit status of 0. So it's simply going to print true. So let's go ahead and run that. You can see, oh, that is false. Let me see what's going on there. Shockingly, what do we have here? I'm saying if variable 1 was greater than 25. Well, we know it's not. Oh, wait a minute. I made a mistake. Of course I made a mistake. So both of them actually are evaluated as false or exit status, because this is false because variable 1 is not greater than 20. And here I'm saying here if variable 2 is less than 10, but in reality, look at it, I have a 20, so it's not. I have to put this as 30 for this to be evaluated as true. And now if I go, and I'll get the true. Yep, that makes way more sense. So those are the AND and the OR operator. Now, one thing you should know that we also have an operator where we can flip the evaluation. And to flip the evaluation of any expression, all you have to do here is to come at the beginning of the expression. Oh, wait a minute, my bad. Let's go insert mode. And I'll just come here and put this as not. And remember here, there's always those spaces. So whatever the evaluation of the expression that I'm going to highlight right now here, where this part here, whatever the evaluation of that, when you use simple here, it's simply going to change it to not. So it's going to flip the evaluation. So if I keep it this way, this is going to be evaluated as false, exit status of 1, and this is going to be evaluated as true, exit status of 0. But because of this not operator, simply is going to be flipped to be false, exit status of 1. So both of them are going to be 1. So you're going to get the false printed on the screen, as you can see at the bottom. So those are the not operator. When it comes to files, and let me go back here. If you want to check for a file, if it's, let's say, it's a file that exists, and you want to check if it's readable and it's writable. So for example, I want to check for those two. If the file exists and it's readable, and the file exists and it's writable, so you want to know if you can read and write from the file. The only way here, you cannot put the -R followed by X or followed by W in some single square bracket. You have to have them separated, and you have to use the AND operator between them. So this is something that you should know. Okay, I am continuing with the PowerPoint, and there's some general information about the square brackets. Now, the square brackets by themselves, they simply trigger a command called a test. And whenever you put a test command between those square brackets, you're simply calling a command called test, and the test command is going to take whatever is between those square brackets and is going to evaluate it for you. Okay, so that's again how Linux simply evaluate the expressions that you have between those square brackets. There is a command called test, and you can give it a try and just go and type test menu and see how does it work. That command again, if you can utilize it, you can use it if you want to, but the idea here is simply those square brackets simply are replacement for a command called test, and that test simply going to evaluate the expression to tell you whether the exit status is 0 or the exit status is 1. So this is something you also have to know. Now, there is another thing that you should know, and we're going to talk about this a lot in the future. There's something called pattern matching or pattern recognition. Pattern matching simply means when you search for text, but you're not searching if they are exactly the same. What is that supposed to mean? I'll tell you. For example, if I have a string, let's call variable 1, and let's set variable 1 to test. And then I would like to know if I can search, okay, not necessarily. Let me just cancel the variable 1. Let's say I have a username. And I want to know if that username starts with a specific letter. Okay? To do that check, instead of using a single square bracket, you have to use a double square bracket. So that will be number one. And then you type, for example, user, and you type double equal. Remember here, this is, when we compare strings, we use a single equal. And then you put, for example, R and asterisk. And I'm using the same example that the book is utilizing. So what is the meaning of this command here? Now remember here, if I'm using a comparison for strings, I go with a single equal. But this time I'm talking about patterns. So what I'm doing here, whatever the value of user is, I'm checking and see if that user starts with the letter R and followed by a 0 or a number of other characters. So for what it matter, that user that I'm comparing it to, if it's a single R, then that's going to be considered as yes, with the exit status of 0, or it was R and a few other characters, which I don't care about those characters. Simply, that will also be considered a true, with an exit status of 0. So again, there should be a chapter, a whole dedicated chapter about pattern matchings, and that should be covered later, because there's a lot of details of how that is possible. Now, I believe we're getting closer to the last part of this class. And again, for those who are coming from a programming background, whenever you learn about selection structures, you learned probably about something called switch statement. Now, for those who have a Python background, switch statement doesn't exist in Python. But what is the switch statement? Simply, again, before we get into switch statements, all the expressions that we had before, the final evaluation simply will give you two cases. Exit status of 0, you perform action. Exit status of 1, you perform another action. And we also talked about, well, we can have a nested if statement just in case we have multiple scenarios to cover. Well, we have a different technique that will fit better, let's just put it that way, whenever you have a situation where you need to take different actions depending on different values. Okay? So the command here is called a case. And I think the better way to understand it is by an example. So let's go ahead and come here. And I'm going to come here and say user. And I'll put, for example, my name. And let's see how this thing works. First of all, let's talk about the syntax. You start with a keyword case, and then you put your variable, which is in this case, user. And you type n. And you follow that by pressing enter, and you start listing your cases. So how many cases I will have? I will come here and start with case number 1. Ahmed. And let's say I want to have this to be matched with 2 different cases. Yeah, I want to take the same action with 2 different cases. So we'll call it, for example, Mark. Okay, so here we go. This is the case. What do we do in a case like that? Well, I will come here and say echo. We'll just call it, for example, match 1. And then after that, I will type another echo. I will say the end. And let's say 1, just for us to know where's the matching happening. Now, the most important part here, to not forget that you should put 2 semicolons here. And let's have another case. This time I'm going to go with Smith. And remember here, you put the parentheses. And then you go down and you put, let's go, echo. I will say match 2. And then I'll put echo again. And I'll say and 2. And remember here, double colon. If you have a single command, then that single command will end with a double colon. If you have 2 commands, then the last one. What's important here, whatever you have inside that block of code, the last command should have two column. And now I'm putting two column not because I have two commands. That simply means if I have three commands, I will have to put three semicolons. No, the last one has to have two columns. Now, so we got Ahmed, Mark, Smith. Let's have a third one. We'll call this one John. And let's go echo third one. And this time, actually, I'm just going to put a double colon here. Now, the last thing here is what we call the default case. And the default case simply is an asterisk. And then after that, you simply tell me what will be the default action that you will take if a no match happened. And in this case, I'm going to put echo. And I'll say no match, for example. No match. And always remember the double colon. So let me just go ahead and explain the syntax here. So we do have a variable called Ahmed, and I'm using the case structure here, and I'm saying this is my variable Ahmed, and I want you to look through all the cases here for a match. If you find a match at any point, perform the action that is associated with that match, and ignore the rest. Okay? So since I found a match here, that simply means this is going to be executed and everything will be ignored. And let's imagine this was Mark. So it could be this one or it could be this one. Whatever you find a match with, take this action. If no match was found, so no match here, no match here, no match here, simply means the default case will be executed, and that's how it works. So let's go ahead and save the work and see what's going to, oh, nope. Okay, syntax error. We're talking about line number 31. Expected an end of file. Oh, yes. I forgot something very important. Just like how if statements ends with an fi, this one ends with ESAC. That's a very, very important one that I forgot about. So let's go ahead and exit. And now let's give this a try. And you can see here, no match. Match one, the end one. Let's go back and change that to I'm just going to put Adam to test the default case. No match, as you can see here. And if I go back here and put John, and remember here, this is case sensitive, so you have to be extra careful. And now you can see here, third one. So this is the case statement. Now again, if you find yourself in a situation where your final evaluation is true or false, then that's a simple if statement. But whenever you find yourself dealing with multiple possibilities and every single possibility will require a special action, then case will be your best friend. I believe this will be the end of this chapter. I hope this video is not as long as the first one. Thank you for watching, and I'll see you guys next week.